Given that the center of the circle is point O, chord AB has the same measure as the radius of the circle, and point C is the midpoint of chord AB, find the distance between point O and point C if the radius has a measure of 60 meters. Basically, the overall goal here is we want to know the distance between point O and point C, right? That's the total, not total, but that's basically the goal, single goal that we're going to do here. All right, what's the distance? The measurement of the distance between point O and point C. All right, so here's what we're going to do first. First is we need to know the given carefully. All right, we have to be analytical. Okay, when it comes to this. So yes, we have the center, which is point O, that's already given. Then next, we have a chord AB, which is already here. When we say chord, basically it's a line that shows the distance between two endpoints in a circle, but they don't pass through the center, right? So just like this, for example, if I have this circle, all right, and this is the center. If I will draw a chord in which the visual would look like this. From this going here, this is still considered as a chord. All right? It shows the distance between two endpoints, which is these two, but they don't pass through the center. Because if they do, that's no longer a chord anymore. All right? Or maybe it looks like a chord, but there's a specific term for that, which is diameter, right? So yeah, now you get it. Now here we have point C as the midpoint of chord AB. Basically, between A and B, there is a middle point which is C. So now we have a given radius which is 16 meters. All right, we have R as 16 meters. Radius rather. So to give you a brief description of what radius is basically similar to a chord. It's a line, but it shows the distance between the center and a given endpoint. So from this to this is already a radius. All right. At any endpoint, it could be from this point or from here to there. Okay, from here to there, this is also a radius. From here to here, this is also a radius. All right. These three are radii, which is basically a plural form of radius. All right. So yeah, and one thing to know that what would be the measurement of this radius? It would be the same in any location. Like for example, if the measurement of this radius is 1 unit long, then the measurement of this one is also 1 unit long. And likewise, in this radius, which is basically located below the center, it's also 1 unit long. If this is 12 units long, then so are the other radii. Okay? So it's 12 units long. All right. So now, let's relate it here though. So if, again, radius is basically the distance between a center and a given endpoint, then I think I can draw two radii. Okay, remember radii is basically a plural form of radius. And please correct me if my pronunciation of its plural form is wrong. But yeah, okay, I can draw two radii, which is from point O, which is the center, up to point B. Since point B is on the curve of the circle, and likewise, I would do the same thing, drawing a radius from point O to point A. All right, that's it. So these are your two radius. All right. Now, again, the length of these two radii, I mean, are the same to each other. So meaning they are 16 meters. Now, here's the thing. Okay, both of them are 60 meters in length, but there's another given here. According here, chord AB has the same measure as the radius of the circle. That means chord AB is also 16 meters in length. All right? So chord AB is also 16 meters in length. Now, what are we going to do? Now, in here, I think we can relate a triangle lesson here. All right? Let's cut this triangular shape because we can say that it is a triangle because it has three sides, you know. So let's cut that segment, all right? So let us draw a triangle that represent this triangle. So we will have it here, right? Let's do this. Oh wait, no, no, no. I'll draw it in a better way. Like this, like this. Wait, no, like this and like that. Okay, we have a triangle. Then the sides are all the same. So all of them are 16 meters. Okay, so don't forget the chord has a wait. The chord has corners A and B. Middle here we have C, and then here we have O, right? C is here. Okay. So now you see this is a triangle. All of the sides are the same. So what does that imply? If all sides are the same, this is an equilateral triangle. Right? This is an equilateral triangle, meaning this triangle has the same measurement of all sides. Right? Correct me if I'm wrong. But basically, you get the point. 16 meters here, 16 meters there, and 16 meters on the base. All right. Now, here in equilateral triangle, here we have another property of it. You know, yes, it has the same sides, but we need also to consider its angles, right? The angles are located on the corners of the triangle, which is here, right? Which is here. And here's the thing. If it has an equilateral triangle, therefore it also has an equiangular triangle. Meaning, if all sides are the same, then all angles are the same as well. So here at point A, point B, and point O, they have the same angle. They are the same. Now, here's a question. What angle would that be? That angle would be 60 degrees. All right? In an equilateral triangle, the angles, the interior angles, basically the angles in the corner of the triangle, they are all the same, in which its measurement is 60 degrees. So equilateral triangle has an interior angle of 60 degrees, right? Okay, so what of it? Okay, we know that all sides are the same and its angles, interior angles to be particular, are the same. So what of it then? Right? What of it if they are the same? Now, here's the thing. What we can do here is that remember that point C is here, right? Wait. Remember that point C is here, right? Which is the middle of A and B. So what I'm going to do here is I'm going to draw a bisector going to the mid, going to the point C. Basically, think of it like as if I'm going to make a line between point O going to point C. Right? Let me use a red color. From here, going here. Right? Going here. Wait, let me fix that. Right? So from here, going here. That's it. So what happens if I draw a line from O to C? What happens is that the equilateral triangle cuts into half. Okay, it cuts into half. All right. So what happens if it cuts into half? So this 60-degree will be divided by 2. All right. In which we will have 30 degrees on each side. So we will have 30 degrees here and 30 degrees here. That's it. All right. And likewise, now that we cut the triangle into half, this 16 meters, we can divide it into two, in which we will have 18 meters on 18 meters, 8 meters on both sides. So from A to midpoint, we have 8 meters, and from midpoint to B, we also have 8 meters. All right. Then after that, we can pick which side of the triangle we're going to use. Right? For me, I would rather use the right one, like this part. This part. I would rather use this one. All right? So with that, I'm just gonna draw another right triangle like this. All right, like this. And then I'm gonna put the corners. So zero, O, then this is C, this is B. All right. Then we're going to put the given measurements. Here we have 16 meters. Here we have 8 meters. And then let's put also the angles. So from point B, we have 60 degrees. Here we have 30 degrees. And here we have a right angle. Why is it that we have a right angle? Because you see, we have like a vertical line and then we have a horizontal line. So if we have an intersection between vertical and horizontal line, then the angle between them is a right angle, meaning the vertical line and horizontal line, once they intersect, they are both perpendicular to each other. So hence, between them should have an angle of 90 degrees or a right angle. So that's it. Now, here's the thing. We have 16 8 meters. Now, let's find OC, right? Let's find OC. So, how are we going to find the length OC? It is very easy actually. It has like two ways for you to solve this one. Like, what would be the measurement of OC? Because once we found the measurement of OC, that will be the distance, the measurement of the distance between O and C. So, what are we going to do? Let's start first with the first, let's start first with the first thing that we can use if you want to do it in simple way, which is Pythagorean theorem. All right, let's use Pythagorean theorem. All right, let's try to use that. Pythagorean theorem. All right. So let's have a recall when we say Pythagorean theorem. When we say Pythagorean theorem, in a given right triangle, like this, for instance, okay? So here, let A be the vertical side, B as the base, and C as the hypotenuse side, which is basically the longest side of the right triangle. The sum of the square of the legs, which is basically A squared plus B squared, is equal to the square of the hypotenuse, C squared. All right? So we can apply this formula in this problem. All right, we can apply this formula in this problem. So here, all right, let's just say our hypotenuse is 60 meters, our base is 8 meters, and our, what do you call this one? Our vertical, let's just say this is A, right? Then let's substitute. So our A is what we're looking for. A squared plus your B squared, which is basically the square of 8 meters, is equal to C is the square of 16 meters. All right. So let's find our A in this equation. The square of 8 meters is 64 meters squared. 16 squared, I think that's 16 squared. 256 square meters. 256 square meters. Then, by finding A, we will transpose 64 on the right side. So we have 256 meters squared minus 64 meters squared. Combine them together, 256 minus 64. That will give you 192 square meters. 192 square meters. Then we're going to square root both sides to find our A. So here, if we square root both sides, 100 square root of 192 is 8. square root of 3. And that is your answer. All right. So if your A is 8 square root of 3, all right, that means your OC is 8 square root of 3. And therefore, that is our answer. All right. Easy. Pythagorean theorem. Well, there's another way for you to do that. In terms of another way for you to do that, here, this is, I think, the easiest of the two. Basically, this second method is easier than using Pythagorean theorem. Like when you're too lazy to do solving, you can just use this second method. So the second method is the application of a special right triangle, which is 30-degree, 60-degree, 90-degree right triangle. Let me put it here. So to give you an idea, this special right triangle, it's considered special because it can tell you what would be the measurement of each side. Even if it's in square root form or whatsoever, it will tell you exactly the sides, the measurement of the side of the, what it calls one of the right triangle. All right. So in this case, to give you a visualization, we have this one. Okay. So we have this one. Let's just say that we have 60 degrees here. We have 30 degrees here. All right. Right angle, 90 degrees. Right. And we have hypotenuse. So here's the thing. You have a given hypotenuse. If you want to find the measurement of this side where it is adjacent to 60 degrees, or basically a side that is beside 60 degrees, all you need to do is divide the hypotenuse by 2. Again, if you want to find the measurement of the side where it is beside 60 degrees, just divide the hypotenuse by 2. Then, here, how about if it's beside 30 degrees? Here, if it's beside 30 degrees, all you need to do is you have to multiply the hypotenuse by square root of 3 and you divide it by 2. That's it. That is also the same thing where, let's just say, 60 degrees on top and 30 degrees is below. All right, like this, for instance. Okay, like here we have 60 degrees and here we have 30 degrees. So it's just the same. All right, if you have a hypotenuse here. So again, if it's beside 60, hypotenuse divided by 2. So this vertical side is beside the 60 degrees. So we will have hypotenuse all over 2. Then here on the bottom, which is the base, which is beside 30 degrees. So you will have h squared of 3 all over 2. That's it. Now let's relate that here. All right, let's relate that here. So I'm just gonna copy this one and I'll put it here. That's it. So here's the thing. All right, this is missing. Okay, here we have the hypotenuse, which is 60 meters. All right, that is your hypotenuse. Okay. Now, to find the measurement of side that is beside 60 degrees, all you need to do is divide it by 2. So let's take a look. H all over 2 is 16 meters all over 2, which give us 8 meters. So it is in fact correct. Now, how about to the length OC, or a side that is beside 30 degrees? So you have h square root of 3 all over 2, which is 16 meters times square root of 3 all over 2. This will give us exactly 8 square root of 3 meters. So the answer here for this problem is 8 square root of 3 meters. And the same thing for Pythagorean theorem, the answer is 8 square root of 3. All right? So the answer, once again, is 8 square root of 3 meters. And that's it.